All right, hello everybody. This is Kendrick from the Digital Logic Online section. And today I'm going to be going over my binary operations and showing you how to do it. So first of all, we're going to start by addition. So binary addition is a lot like base 10 addition. It's a really similar process. The only difference is pretty much how carrying works. So I'm going to show you all that right now. So as you can see here, we've got the numbers 1, 0, 1, 1, 0, 1. And also we have 1, 1, 0, 1, 0, 1. All right. So we're going to be adding these two numbers together. So first of all, so we're going to add the right column, just like regular addition. So as you can see, it's a 1 plus 1. So usually in base 10, we would make this equal 2. But that's not actually true in binary. How binary works is once you get to 2, you carry a 1 over to the next column. So, and then instead of the 2, we're just going to put a 0. So if you, right here, 1 plus 1, it's actually we're going to put a 0 here and put a 1 up here. And see, that's pretty much it. It's the same rules as regular addition, except for it's kind of modified a little bit to fit a base 2 format instead of base 10. So over here, 1 plus 0 equals 1. 1 plus 1 equals 2, which would make a 0 plus a 1 over here. 1 plus 1, that's a 0 and a 1. 1 plus 1, that's a 0 plus a 1. Now this is where it gets a little tricky. So we have a 3 here, which if you think about it instead as a group of 2, which you would carry, plus 1, it makes it a little bit easier. So since we have a group of 2, we're going to cross these 2 out and we're going to carry. And now we only have 1 left in this column, which we would put right here. And now we have an extra 1. And you see there's no numbers over here. But we wouldn't just get rid of it because that's not how addition works. So we would just tack it on to the end. And here's our answer right here. 1, 1, 0, 0, 0, 1, 0. So this is the answer and this is how to do binary addition. So on the other side, now we're going to do some binary subtraction, which like the addition, it works pretty much the same as base 10 subtraction, but it's just a little modified. So I'll write out our things right here. 1, 1, 0, 0, 1, 0 minus 0, 0, 1, 1, 0, 1. All right. So first of all, we run into a problem. We can't subtract 0 and a 1 because that's negative. So what we would have to do is we would have to borrow, just like we do in regular subtraction. So first we'd mark this 1 out. Well, we could put a 0 here. And instead of bringing a 1 over like we would in base 10, we're actually bringing a 2. So now we would subtract the 2 from the 1, and that would equal 1. See, it's pretty much the same. We go 0 minus 0. That's 0, of course. 0 minus 1. See, now we have to borrow again because we can't subtract 1 from 0. So we're going to cross this out, put a 0 up here to show that we borrowed. We're going to put a 2 here. And now we're going to have to carry again because see, we can't bring it from here to here directly. We have to go through this one first. So what we do is we cross this out and put a 1. Now we'd go and put a 2 here. So now this would be 1 because 2 minus 1 is 1. Over here, we've got this 1 left over from carrying. 1 minus 1 is 0. 1 minus 1 equals 0. So let's put that right here. 0 minus 0, that's easy, that's 0. 1 minus 0, it's 1, just like regular subtraction. And all right, here you go. Here's our answer. See, it's a pretty simple process. It's just a little bit changed from regular base 10 versions of this. All right, here we go. Now we're going to multiplying. This is a little bit more complicated, but not really. So pretty much multiplication, it's pretty simple rules. If you multiply a 0 and a 0, that equals a 0. If you multiply a 0 and a 1, that equals 0. If you multiply a 1 and 0, that equals 0. But if you multiply a 1 and a 1, it equals 1. So pretty much, unless you're multiplying a 1 and a 1, it's going to be 0 when you multiply. And I'll show you kind of how that works right here. So what we're going to do is we're going to go 1101 times 111. All right, so we're going to just do the same thing as we do in regular multiplication. So we're going to multiply this by this. And since it's a 1 and a 1, that is a 1. So we go 1. Okay, we're going to multiply this by this. 1 and a 0, that's a 0. All right, 1 and a 1, that's a 1. 1 and a 1, that's a 1. And now, like you do when in regular multiplication, when you move to the next digit, you need to add a 0 first. And now we're going to get multiplying again. So this is a 1. 1 times 0, that's a 0. 1 times 1, that's a 1. 1 times 1, that's also 1. So here we go. We've got the second row done. Now we're on to the last digit. So what we're going to do here is the same thing except we're going to add 2 zeros because that's what you do in regular multiplication. So 1 times 1, that's 1. 1 times 0, that's 0. 1 times 1, that's 1. 1 times 1, that is also 1. So as you can see, it's a pretty simple process. So I'm going to move the thing over here so that I can add it more easily. So I have more space. But at this point, this is still the same process. What we're going to do is we're going to now we're going to add them together like you would do in regular base 10 multiplication. So 1 plus 0 plus 0, that's 1. 0 plus 1 plus 0, that's also 1. 1 plus 0 plus 1, that's 2, which you remember, as I explained earlier, once you get to 2, what you would do is you'd put a 0 here and add a 1 to the next column. So over here, 1 plus 1 plus 1. All right, so as I said earlier, what we would do, we can think of it as 2 plus 1. So we could do 2, take the 2 out, put a 1 here, and then it's just a 1 in this column. So 1. Same thing here. This is 2 plus 1. Over here, 1 plus 1. Okay, that's 0, and move one column over. And there we go. Here's our answer. 1 0 1 1 0 1 1. It's that simple. It's pretty much the same process. We just had to modify the carrying rules in order to fit a base 2 format instead of a base 10. All right, guys, now that we've finished that question, it's time to go to the next one. So problem 4, convert the decimal number 57.6 into a floating point number. So this one is a little bit more complicated than the others, not because it requires more advanced equations, but just because it just has more steps. And I'll show you a bit why it's a little bit more complicated when I work through it. But first, I got to explain what the end product is going to be. So in order to comply with the format we're going for, we need to have 3 different sections. We need to have the sign section, which is either going to be a 0 or 1, depending on a 0 for positive, a negative for 1, and that just depends on the sign of the number we're converting from. Next, we're going to have an 8-number section called the exponent, which tells the exponent of our number that we're doing. It's because we're kind of doing a thing that's similar to scientific notation, but not exactly. But don't go too deep into that because that's not as important. Finally, we've got the Mantissa. So this is a 23-number sequence that shows pretty much most of the numbers that we are. That's the actual numbers that's in the floating point. So yes, we have the sign, which is a 0 or 1 depending on the sign. Exponent, I'll show you how to get that later. And Mantissa is the number after we convert it to binary. That's going to be the actual number. All right, so let's just get started. So I'm gonna put the answers right here. So here's the line, and we'll get that filled out in 1 second. So first of all, we're gonna start with the sign, the first part. It's 57.6. A 0 equals, you write a 0 when it's positive. You write a 1 when it's negative. So this is positive. As you can see, there's no negative sign set in front of the 57. So we're going to put a 0 here for the sign area. Now we need to convert the 57. We need to convert the whole number to binary, but we're going to start with the 57. There's many ways to do this. I'm the way I'm most comfortable with, I will show you. So first of all, we're going to write down 8 sections, 8 numbers for binary. You know, we got 1, 2, 4, 8, 16, 32, 64, 128. We're going to write that down right here. So we're going 128, 64, 32, 16, 8, 4, 2, and 1. As you can see, we've got the 8, because this signifies each place, the value of each place in binary. See, the first one's 1, 2, 4, 8, 16, 32, 64, 128. So now we have to figure out how we're going to use this to convert 57 into binary. So how to do this is we get the number 57. We have to find out which is the largest number on this line that fits into 57, which in this case is 32, because 64 is larger than 57, so it can't fit in there. So we're going to put a 1 at 32. And so then we subtract 57 from 32, which would be 25. So we got 25 now. So now we have to go to the next number. So 16, does it fit in 25? Yes. So now we put a 1 here, and we subtract 25 minus 16, which is 9. So now we've got 9. So does 8 fit into 9? Yes, it does. So we're going to put a 1 here. So 9 minus 8, that equals 1. So this is where it's a little different. Does 4 go into 1? No, it doesn't, because it's much larger. So we're going to put a 0 in here. Does 2 fit into 1? No, it's also larger. So I'm going to put a 0 here. Finally, does 1 fit into 1? Yes, it does, because that's the number. So this is 57 in binary form. It's that easy. So what we're going to do is down here, I'm actually going to write it out. 1, 1, 1, 0, 0, 1. So this is the whole number, 57, in binary form. But now we have to get the decimal form. And there's also different ways to do this, but I'm going to use the way I'm most comfortable with as well. So how this works is we get the decimal with whatever number's in the decimal portion and multiply it by the base, which in this case, since we're converting into binary, it would be base 2. So 0.6 times 2, that is 1.2. Very simple. So we're going to write 1.2 here. And so pretty much happens is when we have the 1.2, if there's a 1 in this left portion, what we're going to do is actually separate it from the number in the decimal. So we're going to act like this 1 isn't a part of the 2 anymore. It's just 0.2 now. And so now that they're separated, we're going to multiply 0.2 by 2, which is 0.4. And then, so 0.4, that's a 0. So we don't do anything when there's a 0. So now we're going to keep going. 0.4 times 2, that's 0.8. So another 0. But here it goes again. When we multiply this by 2, we're going to get 1.6. And again, we have a 1. And again, when we're going to separate it from the 0.6. So it's not part of the 0.6 anymore. It's just 0.6. And you'll see why we do this in a little bit. But 0.6. 0.6 times 2, 1.2. All right, so now we just separate it again. And now it's just 0.2. So 0.4, 0.8, 1.6. And again, we separate it, so now it's 1.2. And we're gonna do this until we have 20, pretty much 20 digits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 right now. So we get one more. That's, we're gonna do 0.4. Now we're at 10. So now pretty much we're gonna do it 10 more times. All right, here we go. We've got all 20 digits. So what I'm gonna do is I'm gonna fill the empty parts in with zeros, because you'll see why we do that in 1 second. So pretty much by doing this, we've gotten all the digits we need for the decimal portion. So what we're gonna do here is we're gonna write it out side by side like you would do a normal number. So what we're gonna do is we're gonna start from the top and go all the way down. All the numbers on the left are the ones that go in the binary. See a 1? The reason why we separate is because we're gonna write down the 1 as our binary 1, and zeros, that's gonna be our binary zeros. So we're gonna start at the top. 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1. All right, so now what we need to do is we need to kind of change the notation of our number right here. So how we do that is we need to put the decimal point in right after the first one, which, as you can see, this is the first one. So that means it would go right after. So to do that, we need to go 1, 2, 3, 4, 5. So the new decimal is going to be right here. And we got to make sure we keep the 5 for later, because that's going to be important. All right, so let me write down the number again, but with the new notation. All right, so we've got the new notation written down, and everything's going smoothly right now. So now, using this 5, we're going to find the next notation. Not the next notation, the next section of the number we need. We're going to find the exponent. So to find this, we have to add 127 to the 5. So 127 plus 5. It's pretty simple math, but I'll do it out here for you just so you can see. 7 plus 5, that's 12. And we're actually doing this in decimal, base 10, this edition. So 7 plus 5, that's 12. We're going to go carry the 1, so that's 3, 132. All right. So now we have to convert this 132 into decimal. So, and what we can do it right here. We just used it, so let's use it again. So 132, 128 fits into it once. That's the largest one that'll fit into it. So we'll put a 1 down here. And now we have to subtract 132 by 128, which it's a pretty simple addition. It's just 4. So now we're going to see wherever else this fits in. 64 doesn't fit into 4, 0. 32 doesn't, 0. 16 doesn't, 0. 8 doesn't, 0. But 4 does, because that's the number. So I'm going to 1, 0, 0. And here we go. We've got our exponent right here. It's this 8-digit number, 1, 0, 0, 0, 0, 1, 0, 0. Let's write it down here. 1, 0, 0, 0, 0, 1, 0, 0. See, we've almost got all of our numbers. Now we just need to find the mantissa, which isn't really that difficult once we get to this point. So now what we would do is we're going to find the mantissa, what we need to do is we need to get rid of this leading 1. And that's kind of a way that they made it so they could store more digits. So we're going to get rid of this leading 1, and then we're going to count 23 digits. because that's how many digits are in the Mantissa. So we're gonna cut off these last two. And here we go. So now we just write this number up here. 1 1 0 0 1 1 0 0 1 1 0 0 1 0 0 0. Let's make sure we got all the numbers. And here we go. We just converted it into the floating point format. So yeah, it is a little bit more complicated. It does take a few more steps, but there it is. It's really easy math. It just takes a little bit. All right, now that we've finished that one, it's time to go into the last question. This one, problem 5, convert the decimal number negative 23.3 into a floating point number. All right, so as you can see this time, it's negative, but the good thing about the way we're doing it in the format is that it being negative doesn't really mess up too much, and I'll show you why. So what we're going to do is put our line here again, because this is where we're going to put the answer as we get it. All right. So now, first of all, it's a negative. So now the last one was positive, but this one is negative. But the only difference is, you remember that sign area, the first number that indicates the sign? Last time, since it was positive, it was a 0. But now that it's negative, it's going to be a 1. So as the first number for our final product, we're going to put a 1. All right, so now everything's pretty much the same. So what we're going to start by doing is going and converting 23 into binary, and then we're going to do the 0.3, but let's do 23 first. All right, so let's do what we did last time. We have 128, 64, 32, 16, 8, 4, 2, and 1. All right, so here we go. 23. 128 does not fit into 23. Neither does 64 or 32, but 16 does. So we're going to put a 1 here. And now, like I did earlier, we're going to do 23 minus 16. All right. So easy. Put the 1, 13, 13 minus 6. That's 7. All right. So it's 7. Does 8 fit into 7? No. So we're going to put a 0. Does 4 fit into 7? Yes. So we're going to put a 1. 7 minus 4, that's 3. So we're going to put a 3 here. Does 2 fit into 3? Yes. So we're going to put a 1. 3 minus 2, that's 1. So we're going to put a 1 here. 1 fits into 1. So we're putting another 1 here. And here we go. We've got our whole number into binary. So we're going to put it down here for later. 1 0 1 1 1. And now it's time to get the decimal portion into binary. So we're going to do exactly what we did last time. Since it's a base 2, we're going to multiply it by 2. And we're going to, we're going to save the 1s and the 0s, and then that's going to be how we're going to get the final the final binary. So let's start that right now. All right, 0.3 times 2, that's 0.6. All right, 0.6 times 2, that's 1.2. And remember, we separate the 1, so that's not part of the 0.2 anymore. It's just 0.2. So 0.4, 0.8, 1.6, 1.2, 0.4, 0.8, 1.6, 1.2. And we're going to keep doing this until we get to 20. All right, guys, so now we've got 20 digits. So we're going to do the same exact thing that we did last time. Remember, we read it from top to bottom, and then we put whatever that was down here. So from top to bottom, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And we're going to keep doing that. 0, 0, 1, 1. And there we go. 20 numbers right there. So what we're going to do now is we're going to convert this into the Mantissa form. But to do this, we have to first take the decimals and the decimal point and move it right before the first one. But let's add a couple more just in case. So now we're at 22. See, this part doesn't actually matter because we're just going to cut off 20 to the 23rd one. But I'm putting extra just in case we don't have enough, because then it would be a little messed up. All right, so here we go. We have to move this over before right after the first one, which is right at this spot. So to do that, we got to move it 1, 2, 3, 4 spaces. All right, so let's put that number here, because remember, like last time, it's going to be important. So I'm going to write this number down again, but in the form without all this mess over here, because that kind of looks weird. So let me do that real quick. All righty, here we go. We've got the whole thing written down. So now it's time to find the exponent portion. So what we are going to do is we're going to add 127 to the 4 that we just found by counting how many spaces we had to move the decimal. So 127 plus 4, that equals, this equals 11. So we'd put a 1 down here, carry the 1, 3, 131. And now we have to convert this into decimal form, in binary form, actually, sorry. So we're going to go, the largest number that fits into 131 is 128. So we're going to put a 1 right here. All right, we're going to go 0, 0, because 131 minus 128. Well, that's just 3, because see, 11. There we go. That's 3. So we have to find a number that will fit into 3, which 64 doesn't, 32 doesn't, 16 doesn't, 8 does not, 4 doesn't, but 2, it does. So we're going to put a 1 right here. 3 minus 2, that's 1. So we got 1. And 1's right here. So that fits in 2. So here we've got our exponent number. So what we're going to do is we're going to write this up here, because this is one of the components of the final answer. There we go. So now, you remember what we did last time when we were at this point? We had to find the Mantissa number. But to do that, first we have to cross off the first one, which is this one right here. So we're getting rid of that. And now we're going to put the rest of this up to 23 digits. So let's just get that done right now. All right, as you can see here, I just wrote down 23 digits. So this is our Mantissa, and this makes our final number. We've got the sign, we've got the exponent section, and the Mantissa. This is our final floating point format. And as you can see, I've got gaps. I've got spaces between the numbers. These aren't actual, you aren't actually supposed to have these. You don't put spaces in between it. This is just a visual thing, so you can see how the different parts of the numbers kind of work into the final answer. But if you wanted to write this down for like an answer, well, you would put them all together. You wouldn't separate it like I'm doing it. So like I'm writing down right here. This is how you would actually write it. But it's a little bit more confusing the way I'm showing y'all. So thank you for watching. I hope y'all learned a little bit, and I'm glad I could help you.